You've seen the headlines, right? Record-breaking floods, catastrophic wildfires, heat waves that are just off the charts. It really feels like we're being bombarded. But what if these aren't just random, isolated events? What if they're all connected? Today, we're going to dig into the science that ties all of these seemingly separate disasters together into one big story about our planet.
Let's get into it.
Just take a look at this. This isn't some photo from a history book. This was Lake Passaquaro in Mexico, completely devastated by drought. When we talk about extreme weather, this is what we mean. This is the real world, heartbreaking impact on people, on communities, on entire ecosystems. Now, to really understand what's happening, we have to zoom out. Because when you do, a trend emerges that's, well, it's impossible to ignore. The frequency of recorded climate-related disasters, storms, floods, droughts, has shot up 5 times since the 1970s. And look, that's not just a little bump. That is a massive, fundamental shift in how our planet's weather system works. Okay, so how do we make sense of that 5-fold increase? Here's our game plan for today. First, we're going to pop the hood on what we'll call the climate engine that's driving all this. Then we'll connect that engine directly to the disasters we're seeing. After that, we'll get into the incredible new science that can actually pinpoint the blame. From there, we'll talk about our new reality of risk, and we'll finish up with the big one. How do we even begin to prepare for what's coming next? So let's just start by getting one thing straight. This feeling that we're living through constant extreme weather, it's not just in our heads. It is a scientifically documented fact. So what's actually causing this dramatic increase? To get that, we need to look under the hood of our planet's climate system. And you can think of it as this giant, powerful engine that's starting to seriously overheat. It all starts with a basic law of physics. Now, don't worry about the complicated name, the Clausius-Clapeyron equation. The idea is actually super simple. Warmer air holds more water. And a lot more. For every 1 degree Celsius of warming, the atmosphere can hold about 7% more moisture. You've got to think of all that extra water vapor as stored up fuel, just waiting for a spark. Okay, part 2 of our overheating engine, the oceans. And the easiest way to think about this is that warm ocean water is basically high-octane fuel for storms. Seriously, when you have unusually warm sea surfaces, you're just pouring raw energy into the weather system. And it's that energy that can take a normal tropical storm and blow it up into a monster hurricane, seemingly overnight. And the third piece of this puzzle is the jet stream, that huge river of air that flows high up in the atmosphere. The thing is, it's getting, well, wobbly. See, it's driven by the temperature difference between the cold Arctic and the warmer tropics. But as the Arctic warms up way faster, that difference shrinks. This makes the jet stream weaker and wavier. The result? Weather systems literally get stuck in place. You know those heat waves or droughts that just seem to go on forever? Yeah, that's why. So, let's recap what we've got. A thirstier atmosphere, supercharged oceans, and a wobbly jet stream. Now let's connect those dots directly to the actual disasters we keep seeing on the news. And the cause and effect here is pretty direct. That thirstier atmosphere, it unloads in these intense, historic downpours and floods. The supercharged oceans, they're the fuel for stronger, more dangerous hurricanes. And that wobbly jet stream, that is exactly why we're seeing these relentless heat waves and droughts that just won't quit. And when these things combine, when a supercharged storm gets stalled by that wavy jet stream, you get something like Hurricane Harvey. I mean, that one storm is estimated to have dropped 127 billion gallons of water. It's almost impossible to even wrap your head around a number like that. But this all leads to a huge question, right? Can we actually point to one specific flood or heat wave and say, yep, that was climate change? Well, this is where the science has gotten really, really interesting. This is the science of blame. It wasn't that long ago, maybe 10 years, that if you asked a scientist this question, the answer was always something like, well, we can't really say for sure. That's not the case anymore. The whole game has changed, and we can now get clear scientific answers. It's a whole new field called extreme event attribution, and it's pretty wild how it works. Essentially, scientists use powerful computer models to compare our world to a simulated world without human-caused climate change. And by doing that, they can say exactly how much more likely a specific event was because of our influence. It's like climate forensics, looking for the fingerprints. And the results they're getting are just wow. There's this group called the World Weather Attribution Initiative. Think of them like a rapid response team for climate events.
They found the 2022 heat wave in India and Pakistan was made 30 times more likely. The floods in West Africa, a staggering 80 times more likely. But, and this is so important, look at that last one. They found the Madagascar drought was not primarily a climate change story. That tells you this is objective science. They just follow the data, wherever it leads. So now that we can connect these dots with real scientific confidence, what does it all mean for us? That brings us to our new reality, this idea of stacking the deck against us. I think the best way to understand it is with an analogy of loaded dice. Climate change hasn't invented a new number on the die, right? It's not creating brand new types of weather. But what it has done is load the dice, so that a roll for extreme heat or biblical downpour is way, way more likely than it used to be. We've effectively stacked the deck against ourselves. And this new reality gets even more dangerous with what are called compound events. That's when you get a 1-2 punch, like a drought followed by a heat wave. And get this, these events only make up about 19% of what happens, but they are responsible for nearly 60% of all the loss and damage. Their impact is just completely out of proportion. And of course, this new reality comes with a staggering price tag. For 6 years in a row now, insured losses from natural catastrophes have topped $100 billion. And remember, that's not the total cost. That's just the stuff that was insured. The real economic hit is much bigger. So this leaves us with one final and I think really critical question. How in the world do we prepare for what's coming? This is the huge challenge of adapting to a planet where the goalposts are constantly moving. The message from all this science is pretty clear. We can't rely on the past anymore to predict the future. The old models that we use to assess risk, they're obsolete. The extreme weather records we're seeing today are not anomalies. They are the new baseline. And those records, they're almost certainly going to be broken again. So the real question for all of us is this. Are we preparing for the world we used to have? Or are we using our imagination, our science, and our creativity to actually prepare for the one that's coming? That's the challenge this science puts right in front of us.